Hi guys, I'm going to make a video over geometric distribution. What I'd like you to do right now is pause the video and fill out your table of contents. We're going to be covering sampling without replacement, which we touched on today, and I apologize for not getting that to you sooner. We're then going to discuss what the geometric distribution is and the conditions for the geometric distribution, which is a new acronym. Instead of BINS, it's BUES, and please notice that that is a W right there. I didn't do a very good job. It almost looks like an N. And then after that we cover the conditions for geometric distribution, we are going to go through an example and also discuss what the mean of a geometric distribution is. Unlike the binomial distribution, we do not need to find the standard deviation of a geometric distribution. And then finally, we will do another calculator help with the geometric distribution. Pause now and write down what you need to do. All right. In sampling without replacement, we have this rule right here. I want you to write down. Again, always pause whenever necessary. Where n is equal to my sample size. And then, hold on, let me change colors. Capital letter N is equal to my population size. Sometimes you know the population size, and sometimes you don't. Like in number 72, I believe it was today, it said they were going to interview 15 students. Well, we can assume that 15 times 10 is 150, and we can assume that that is less than all high school students at the high school. You only have to check this when it's without replacement. I'm going to give you an example here with the dead batteries. Like I said in class today, the probability is going to change by like 1/100th. It is not going to change that much. And as a result, the independence condition still suffices for bins and for BUES. Example 21, dead batteries. Almost everyone has one, a drawer that holds miscellaneous batteries of all sizes. Suppose that your drawer contains 8 AAA batteries. But only 6 of them are good. You need to choose 4 for your graphing calculator. If you randomly select 4 batteries, what is the probability that all 4 batteries you choose will work? It says explain why your answer, the probability that x is equal to 4. So this x right here means good batteries. This 4 right here is we're picking 4. It's the same as this 4. Oh, it's getting a little messy. I'm sorry because it's so small. Out of a total of 4. So I want to know of the 4 that I pick, what's the probability that they will all work? Well, n is equal to 4, so there's your fixed trial. So that's good for a binomial distribution. Your B, let's cover bins. Success is they work, failure is they don't. Independence is without replacement, so I'm going to check my rule up here. 10 times the sample size 4 is 40. Is this less than my total population N? And the total population of N of good batteries is 6. Of all my batteries is 8. So no matter what, this doesn't hold up. As a result, this one right here, the probability of success changes for each battery that I pull out. If you have any questions on this, let me know. Now we're going to move on to a new setting, the geometric setting. It arises when we perform several independent trials of the same chance process and record the number of trials with a particular until a particular outcome occurs. The 4 conditions for binomial setting are the same as bins, with the exception of the W. Your B is the same, your I is the same, your S is the same. Binary is success or failure. Independence is one outcome doesn't affect the other. If it's without replacement, you can check your without replacement condition. Again, number 72 in the homework addresses this. S is your success. The probability of success is the same for each trial. And again, if it's without replacement and suffices, it's not changing that much, so they're considering it still the same. The W is where everything changes. Count the number of trials until the first success occurs. So the W is for your wait time. An example of this I wrote down is the probability that a basketball player's first shot made is the third shot he makes. So the first shot that went in the basket, when I say made, okay, so you made the basket, is the third shot that I should maybe write it as attempts. That might be a better way to phrase it so you're not confusing the made and the make. So I would rewrite it as the probability the basketball player's first shot made is the third shot he attempts. Pause it right now. Write down any questions in your space. You can ask me tomorrow in class or in class if you're watching it during class. So again, everything's the same as binomial setting with the exception of your W. Take a second to glue down example 22. Example 22 is about Monopoly. The random variable of interest in this example is y is equal to the number of attempts it takes to roll doubles one time. Each attempt is one trial of the chance process. Let's check the conditions for the geometric setting. So I did that right here. The geometric setting, binary for B, success, failure. Your success is a doubles. Your failure is no doubles. Take a second to write that down. Pause if you need to. Your I is independent. Each roll is independent of the next roll. You don't need to worry about a without replacement here because we're not taking anything out of a hat. W. We are wondering about waiting to roll. We're saying the number of attempts it takes to roll doubles one time. So how long does it take to get our first doubles? That's what the waiting is. And then finally S. Your probability of success is equal to 1/6 each time you roll those dice. BIWS. Pause it, write it all down, listen to it again if you need to. Part A. Let the random variable y be defined as in the previous example. They mean right here. Okay. It says find the probability that it takes 3 turns to roll doubles. I'm really big into, I want you guys to get used to writing the notation. The probability that x is equal to 3. This means our capital letter X is defined as the number of attempts it takes to roll doubles one time. That means it's going to happen on our third attempt. Okay? X is our doubles. 3 is on our third attempt. So the first 2 attempts, failure, failure, are 5/6. Your last attempt is a success, the third attempt. 5/6 times 5/6 times S. 5/6 to the second power times 1/6. And you can calculate that. I forgot to calculate that in my calculator. I'll do it right now for you. Maybe you can beat me to the punch. And that's equal to 0.1157. Forgive me, I'm going to erase since I put it on the wrong line. The next question says, find the probability that it takes more than 3 turns to roll doubles and interpret this value in context. Well, let's back up here. We have a cumulative distribution. We're going to need a calculator, otherwise it's a pain. I'm going to have some calculator help, but let me show you how to compute, and I'm going to find a new color here. How to compute this probability that x is equal to 3 with a calculator. This is a PDF, and because it's a geometric distribution, we can hit our second vars again on our calculator. We scroll all the way down to geometric PDF. Our probability of success comes first, 1 divided by 6, comma, 3. This will give us the same answer that we got right here. So a PDF is for an equals, always. A CDF now is when we have a greater than or a less than. like we do in part B. The probability that x is greater than 3. So that's saying, hey, we're not going to get doubles until over 3 rolls. We're going to at least do 3 rolls, and then we'll get doubles. The probability that x is greater than or equal to 3 is the same as the probability that x is greater than or equal to 4. Whenever it's a greater than, we're going to do 1 minus. So I'm going to do 1 minus what I don't want. Right here, you'll notice, I don't want doubles on the 3rd roll, the 2nd roll, or the 1st roll. Okay? So I'm going to do a CDF for that. 1 minus geometric CDF, or 1/6 is my P, and 3 is my K. And I get 0.5787. So I'll try to sum it up again for you. The probability that x is greater than 3 is the same as 1 minus the probability of what we don't want. We don't want 1, 2, or 3. And 1, 2, or 3 can be highlighted by probability that x is less than or equal to 3. We now can do a CDF, 1 minus geometric CDF, 1/6, comma, 3. That gives us 57.87%. When we're dealing with the wait time, we're dealing with the mean of the geometric distribution. And they ask a question that might say, I'm going to get a different color again, excuse me. How long can we expect to wait? Remember, expect should kind of ring a bell in your head that means, hey, that's a mean. And our mean is 1 over P. And if I take 1 over P here, my probability of 6 is 1/6. That means I can expect in the long run, oh, I need a new page, shoot. 1 over 1/6 is the same as 6. I would interpret this, now listen carefully, in the long run, if I roll several times 2 dice, it's going to take me at least, it's going to take me about 6 rolls to roll doubles on the first time. Let me know if you have questions on that. In the long run, it will take me about 6 rolls to get doubles the first time. Look this over, re-listen to it if you need to. I know some of you don't like videos, so you can ask me in class. You might be watching it right there. Pause it and come ask me, what did you mean by this? On to calculator help. We know that 6% of people have O negative blood. Now we're going to say, hey, we're running a blood bank. What is the probability that the first O negative person is the 4th person tested? Please write it down as your notation. Again, I helped some of you today on your homework and you weren't writing that notation. That's going to be really important for you when your stress level rises, when you're taking a test. Practice these good habits now so they're just in you when you take that test. You don't even question it. You write your notation. It's slowing your brain down. The probability that the first person who has O negative blood is on the 4th person they test. It's an equal to, that means we have a PDF. In our calculator, we're going to write geometric PDF, 0.06 for the probability, K for the 4th person. Practice that in your calculator now. You're going to hit second vars. You're going to scroll down to geometric PDF, which in my calculator is letter E. I'm going to write 1/6. My K value is 4, and I have the newer one, so I'm pasting it. And I accidentally wrote 0.6, so I got to do it again. Give me a second. And I get 0.0965. 0.09. I lied. 0.0965. No, I didn't. Okay. Next one. What is the probability that the O negative person will be found somewhere in the first 5 people tested? As a notation, that means, hey, it's either going to be the first person, the second person, the third, the 4th, or the 5th. So I'm going to write it as the probability that X is less than or equal to 5. If it's less than or equal to, we should be like shouting, jumping up and down for joy. That's a geometric CDF, and we just put that 0.06, comma 5. Practice it in your calculator. Do it with me now. So I'm doing it right now. I go to my geometric CDF, 1/6. My K value is 5. And I hit enter. And I get 0.5981. So 0.5981. What if, though, what if they say, what is the probability the O negative person will be at most 4 or less than 5 people to get the first O negative person? Okay, less than 5 people to get the first O negative person, or at most 4 people. This looks like this, right? If it's less than 5, we're not including 5. Okay, that means we want 1, 2, 3, and 4, which means I want the probability that X is less than or equal to 4, which changes the distribution. So instead of a 5, I have a 4. People can sometimes get tripped up with that, so make sure you understand. And then finally, it says, what's the chance that we'll have to test at least 10 people before we find an O negative person? Okay, that's the probability that X is greater than 10. So we're going to test 10 people, and then finally on that 11th person, we get it. That means we don't want that O negative person on the 0, 1, 2, 3, 4, 5, 6, all the way up to 10. I'm going to do 1 minus geometric CDF 0.06, comma 10. If it's a greater than or equal to, then I change it to 9, because I don't want that 9, 8, 7, 6, 5, 4, 3, 2, 1 to be O negative. I don't want that. So again, just to summarize, 1 minus geometric CDF 0.0610. Why did I put the 10 there? Well, when probability that X is greater than 10, I don't want the first person through the 10th person to be O negative. So I'm going to find the probability that they are and do 1 minus that. If it changes to the you say, hey, on the 10th person or more, okay, it takes 10 or more people to get there, then I don't want someone to have O negative on 1, 2, all the way to 9. 1 minus geometric CDF 0.06, comma 9. The biggest difference is, I think the most challenging, I should say, is figuring out what that K value is, especially when you are subtracting, when you're doing the complement rule. And you always do the complement rule. One minus the probability of something when you have a greater than or equal to. I always do 1 minus what you don't want. Okay. Let me know if you have any questions. I feel like I stumbled on my words a little bit. I apologize. I should probably write a script out. But then you wouldn't get to laugh at me. So, let's move on. We are finished now. You have time in class to work on work if that is the route you went, or if you're listening to it tonight, you have time, the whole class time to work on things. Your to-do list for the next few days, let me just write it here for you. I'll try to get done by 20, so I have a minute to do it. You have a cumulative review. I am going to make a binomial, geometric, Schoology review on, so you can see, are you doing it right or wrong? And that's going to be due Monday. So in class, I know where to help you if I need to. There's going to be a book assignment that's dealing with the geometric distribution that you can work on in class after you finish the video, or you'll have the whole class hour, obviously, if you watch the video tonight. And then finally, you'll get a review assignment, hopefully tomorrow, but it may have to come Monday. The goal is just to answer questions off of this Schoology review on Monday. Okay? And then the next goal after that is just for you to have work time on this review assignment. Let me know if you have any questions. Thanks, guys.